Hey guys, welcome back to Maths Recovery with Rebecca. So today we are going to be looking at adding and subtracting like terms. Now this is the very first introduction that you'll ever get to algebra. So they normally teach you this in grade 7 and then you go from there. And then it just gets exponentially more tricky, which is what algebra is all about. Okay. So let's look at some terminology. So at the moment, we are looking at something called an algebraic expression. Okay, so it's literally just a sentence of maths. As you can see, it's got some x's and y's. It has some letters in it. It's just a phrase of a certain number. So maybe this whole thing adds up to 20, who knows? Okay, this expression has 5 terms. Now, terms are separated by addition and subtraction. So here's a subtraction, an addition, a subtraction, and another subtraction. So let's look at these terms. So I've got 1, 2, 3, 4, and 5. 5 terms. Another thing is, let's go and zoom in to one of these terms because they are broken up into pieces and I am going to label these pieces for you. Okay, so the first thing that we're looking at here is called a coefficient. So a coefficient is just the normal number, the real number that's now in front of your power. This whole block. Can't spell. This whole block is called a power. Then the power is broken up into 2 pieces. You've got your base and your exponent. There we go. So each of these have one of these things. Okay. So we look at this first term. There's a 1 over here. So that's your coefficient, your base, your exponent. Your coefficient is -4. You've got 2 bases here, a base of x and a base of y. Here your coefficient is 7. You've got a base of z and you've got an exponent of 2. So also when I go back to this -4xy, your exponents here are 1. Okay, so let's look at this next one. So you're going to have a coefficient of -4, a base of x with an exponent of 1, and base of y and exponent of 2. And then you're going to get this guy that pops on the back. Now he does not have any variables. Now a variable is a letter. It's just another name for, like, x is a variable, y is a variable. So this guy that does not have any variables is called a constant. And the way that I remember it is that he is constant. He doesn't change. -10 will be -10 forever. But remember, these values of x and y actually have a physical value. We just don't know what it is yet. But because they have a physical value, this -4 will not stay -4. It will be multiplied by whatever x is and whatever y is squared. That's what's going to happen there. So that's why we call this a coefficient, because it has the ability to change. Okay, let's look at the next thing. Now, what are like terms? Now, the definition that I keep on finding is like terms are terms that are like. Well, that's very broad because you and me are like, because we are both humans, but you might have brown hair. I might have blonde hair. You might have blue eyes. I might have brown eyes. So the word like is very vague, which is a problem for me because the terms are not like. Their terms are exactly the same when it comes to variables and their exponents. So let's look at this, for example. Now, is there any other term, because you can see there's 1, 2, 3, 4, there's 5 terms here. Is there any other term that has an x squared only? No. Is there any other term that has an x, y only? No. But look here, you're going to probably think that these two are the same because it also has an x, y, but the exponents are not the same. Therefore, they are not like terms. So you've got z and the square, nobody else, and there's also no other constant around. So as you see this expression, it is already in its fully simplified form. Okay, let's look at this example. Now, we're going to go and look for like terms. Is there any other term? Because how many terms do we have here? 1, 2, 3, 4, 5, 6 terms. So is there any other term that just has an x to the power of 1? Well, right here, that has an x to the power of 1. And then we ask ourselves, is there any other terms that have an x to the power of 1 and a y to the power of 2? Here it is right here. X to the power of 1 and y to the power of 2. Great stuff. Now let's look at our next one. Is there any other term that has an x with the power of 2 only? No. And then let's look at our last one. Is there any other term that has an x to the power of 1 and a y to the power of 1? No, there's not. So now what we're going to do, here's our little law, terms with the exact same variables and the exponents. So we've already grouped them. We are going to just do this. We're going to take the ones that are like, and we are going to add them or subtract them depending on what their operation is. So here I've got a 3 minus a 7. That's going to give me a minus 4x. Here I've got a 5 plus a 4. So I've got 9 of these. I've got 9 xy squares. And then there was no other one that looked like this. So I've still only got 2 of them. And there was no other one that looked like this. Still only got minus 6 of this xy. Okay, let's go see a way, go look for a way that they can catch us out. Now, let's look at this first. I'm just going to change my color to red. We're looking for another term that has an m squared n. Well, this has an m squared and an n. The only problem is that it's not in the right order, but that's fine. If we go look at any term, this one, let's look at this one, this first one. Remember, all of these between all of them is actually a multiplication. So I can go and write this like that. I can go and write this like that. We just like having the coefficient in front. But both of these are like terms. So yes, that is true. Those two are the same. Just remember when you write it out, you've got to make sure that you write it back into alphabetical order. Let's use another color here. Is there any other term that has a m1 and an n1? Yes, right here. So remember, if there is no number, it's always a 1, because it means we have one mn. Here's another one, mn. Okay, let's go simplify this. So the red ones, minus 4 plus 9, that's going to be a 5. So I've got 5 of these. And here I have 1, and then I'm minus 1. So I have no more of those left, because 1 minus 1 is 0. And there we go. Okay, so you can pause it, do these ones by yourself, and see how well you do. I'm sure you'll do really well after that explanation, but I don't know if I'm maybe just tooting my own horn. But let's take a look. Okay, so, well, constant and a constant. So that's going to give me a positive 1. Then I've got this like term, because it's m1, n1, and there's another one, m1, n1. So that's going to be a plus 5, m, n. And then this one doesn't have any friends, so he just pops on the back. Well done if you got that one correct. Let's look at this one. Well, here's a p cubed, here's another p cubed, but this one's just a p to the power of 1, so he's not part of the group. 12 minus 7, that's 5p cubes plus 4p. Remember, we can't add these. We can't add 5 plus 4 because this p is the power of 1. It's not to the power of 3. And let's look at this last one. Here's a squared b, and here's another a squared b. So that's going to leave me with a 10a squared b, and then a minus 5ab. Remember, we can't add these together because this base of a has a power of 1, and it needed to be a power of 2 for these two terms to be like terms. Okay, so hopefully you got that, and you'll see me in the next video. We'll be doing distribution. Okay, see you there. Please follow, like, subscribe, share for the support. Thanks so much, guys.